Good day, Dr. Shane here. Hey, today, heading into the fall, I thought it might be fun to talk about the vitamin D and how we have a better understanding of the impact that vitamin D has on not just simply our internal cellular operations, but in addition to, all roads lead back to the microbiome, of course, not just in my world, but in reality. So vitamin D, as we've all come to know it, is an important molecule that really shouldn't be classified as a vitamin. In fact, it functions more like a hormone. It can affect all of these systems, the endocrine, paracrine, autocrine systems, and not very much like a vitamin at all. However, while we still call it vitamin D, I want you to think of it more as a hormone that really influences how our genetic expression happens. And it does that through something we call a vitamin D receptor. Vitamin D receptors they line all kinds of tissues, and most importantly, when it comes to the new role that it plays in the microbiome, there's vitamin D receptors that line the entire lining of our GI tract, or our gastrointestinal tract. And because of that, there's been a number of research papers published clinically and in basic research where this impact of orally consumed vitamin D and potentially sun-derived vitamin D impacts the GI tract. And what that means is the vitamin D, when it binds to vitamin D receptors in the intestinal tract, it modulates the immune system, specifically the immune system that relates to our microbiome. In addition, it modulates the tight junctions, or the otherwise known as leaky gut effect. So in both cases, vitamin D receptors, as they bind vitamin D, affect us in a positive direction. So a lack of vitamin D leads to a number of unwanted outcomes. First and foremost, we know that low vitamin D levels create an immune issue. That's been known for a very long time because it does have this genetic role in upregulating our immune system. However, it also has been shown to regulate how well our GI tract functions, like leaky gut, for example. Low vitamin D levels impacts the ability for our body to create these tight junctions through zonulin mechanisms. And in the course of that, it now has been shown to modulate the microbiota. And when you think of this, taking a step back, we know that the microbiota has a direct relationship to our immune system, which is one of the key roles of vitamin D. So it's not surprising that vitamin D plays a role in our immune and microbiota. Furthermore, vitamin D acts like a hormone, and we also know hormones have a direct relationship with our microbiota. So on both cases, these two pathways, we now know that vitamin D affects the microbiome through immune and through hormonal interactions. And one of the ways we know that, and as you read the literature, there's a number of good reviews where when people are low in vitamin D, you tend to have a gut that is more populated by unwanted organisms, and it's less diverse. It has less alpha and beta diversity, and it's in a state of what we call dysbiosis. Now, when you have sufficient amounts of vitamin D, the opposite is true. You have a greater diversity, alpha and beta, and you also have what we call eubiosis, or a healthy biosis. And this, of course, then stimulates a more healthy immune system and a more healthy tight junction or leaky gut. Now, that's just the local effects. There are then a lot more systemic effects by having a healthy microbiome and a healthy vitamin D level. Your impact is greater throughout the entire body, as we know. But it's important to understand that we then have this benefit of both orally taken vitamin D, whether it's through supplements and food, as well as light stimulated. But as we enter into the fall and winter, it's harder to get that light vitamin D, so you need to be very aware of that process. And one last thing that drives some interesting personalized approaches to this is many of us carry what are called polymorphisms in our vitamin D receptors. And we look for those in genetic tests, but these polymorphisms impact the binding or the vitamin D receptor function, and it requires more vitamin D intake and in combination with more sunlight exposure to get vitamin D levels up when you actually lack a healthy vitamin D receptor genetically. So these people are more prone to having when their levels drop to not even what we consider a really low level, but a moderately low level, the impact of low vitamin D will be greater to people that have these genetic polymorphisms. So in summary, three things. Make sure you keep your vitamin D levels up, either supplementary, dietary, and sunlight. If you can, look at your genetics. And also, we want to establish a healthy microbiome, meaning, again, dietary and probiotic effects. And all of these things will help your immune system and your gut especially during winter when we don't have the available sunlight. And of course, this will help us really tackle when we all start to end up more indoors and spending a lot more time in areas of a more congested, less free air, less natural air. We're going to be exposed to more organisms, and our immune system needs to be ready for that. So I hope that was helpful. We love our vitamin D, and it does impact our microbiota. And thanks for joining. Bye.